Hi folks, welcome to the Chapter 6 Key Concepts video for Rationals in Math 521B or Pre-Calculus 11. This is the second part of the Chapter 6 roundup, and we're dealing with nested or complex fractions, rational equations, and some word problems. The standard disclaimers apply, and as always, you can check the video description below for a downloadable copy of the notes. So to begin with, we'll look at these complex fractions, or I like to call them nested fractions. There are two approaches. One is to simplify the top and the bottom first. So you'd say, okay, I need a common denominator of x on the top, so I'm going to have to multiply this by x over x. Same thing for the bottom. That's going to be x over x. Okay, so in my next step, I will have 2x over x plus 1 over x divided by 2x over x minus 1 over x. Okay, we'll keep going. So that means I can combine the top, and the big fraction part's in the middle here. 2x minus 1 over x. Okay, now I can flip and multiply. And we could be dealing with restrictions here, but we're just going to ignore them for the moment because we dealt with them a lot in the last video. And we've got the idea. So now we flip and multiply. That means we've got 2x plus 1 times x over x times 2x minus 1. These divide out, leaves us with 2x plus 1 all over 2x minus 1. That approach is going to work fine, but sometimes it's not the quickest way to go. So I'm going to show you a second approach that would also work for us. If we found the LCD of all the little fractions, well, there's a little fraction with an x, another one with an x. So the LCD of the little fractions is just x. I'm going to multiply the top and the bottom of this whole fraction by x. So that's going to give me 2x plus x over x all over 2x minus x over x. Or 2x plus 1 all over 2x minus 1. It gets rid of that nested fraction or that complex fraction situation very quickly. We'll do a couple of examples like this, and then we'll move on to some equations. So if we were to do this the first way round, if we want to find an LCD for the top and an LCD for the bottom, the LCD for the top is going to be m squared. So I'm going to write this whole problem down. And the LCD for the bottom would be m. So that would mean multiplying this by m squared over m squared, this by m over m. In our next step, we're going to have m squared over m squared minus 1 over m squared all over 2m over m minus 2 over m. Okay, so on top we have m squared minus 1 all over m squared. On the bottom we have 2m minus 2 all over m. This is taking a lot of space. Now I'm going to flip and multiply m squared over m squared times m over 2m minus 2. I should really factor these so that I can see what's going on. Maybe there's something that can divide out. So m squared minus 1 is m plus 1 by m minus 1 all over m squared. M by 2 over 2 by m minus 1. Okay, there is some stuff that can divide out here. These are gone. M over m squared is just an m on the bottom. So we're left with m plus 1 all over m times 2, or better yet, m plus 1 all over 2m. And again, that's ignoring the restrictions. So that works out fine. We know how to add and subtract them. Let's try the other approach. The LCD of the little fractions, well, there was an m on the bottom, and there was an m squared. So the LCD is going to be m squared. So this is option 2. It should get us to the same answer. So we said multiply the top and bottom of the big fraction by that LCD. Let's see what that gives us. That's going to give us m squared minus, this will be m squared over m squared, so that's just 1. And the bottom is going to give us 2m squared. And let's think about what happens here. If I have 2m squared over m, that's just 2m. Okay, we don't need this calculator at all. I can factor the top. Factor the bottom. 2m's a common factor. And very quickly, it gets us to our answer of m plus 1 all over 2m. So this is a slick way for us to deal with those nested or complex fractions. You can do whichever way you prefer, though. Number 2, rational equations. They involve variables on the bottom of fractions. So that means you're going to have to look out for non-permissible values or restrictions. We'll multiply both sides of an equation by the lowest common denominator, and then we'll solve. And finally, we need to check that the solution is not restricted or wasn't a restriction. Okay, so we can do anything we want to an equation as long as we do the same thing to both sides. In this one over here, a, we've got 4 over x plus 6 equals 2. Now, it's true we could move that 6 over first, but just to get the hang of it, let's look for the LCD and do it by getting rid of our fractions as soon as possible. So the LCD here is x. The restriction is x cannot be 0. So if we solve this and find that the answer is 0, we'll have to discount that solution. And now I'm just going to multiply both sides of the equation by x. So x times 4 over x, that will just give us 4x over x, or 4. X times 6, that's going to give us 6x. And 2 times x will give us 2x. From here, we just solve normally. So we can say 4 equals negative 4x, divide by negative 4, and we get x equals negative 1. We have to check, was that a restriction? No, the only restriction was x equals 0. This works. If you wanted to, you could sub it back in. So we could say 4 over negative 1 plus 6, does that equal 2? Yes, indeed it does. So x equals negative 1 balances the equation. The next one, we've got denominators of m minus 2 and m plus 4. So the LCD here is just going to be m minus 2 and m plus 4. And then we have restrictions of negative 4 and 2. Now, some people call the technique in this cross-multiplying, but I like the idea that we're doing the same thing to both sides. And the idea of cross-multiplying only works if you have two terms. If we had something else happening on one side, then we'd have trouble. So what I'm saying is we're going to multiply both sides by the LCD, m minus 2 and m plus 4. Okay. So that preserves our equality. We did the same thing to both sides. And you can see right here, m minus 2 on top, m minus 2 on bottom. Those are going to be gone. We'll just have m plus 4 times 1. So that'll give us m plus 4. On the other side, we'd have an m plus 4 on top and bottom. Those are gone. So what are we left with? 5 times m minus 2. So 5m minus 10. Let's go back and finish this off. We'll say 4m equals 14, or m is 14 over 4. So m is, you can call it 7 over 2 or 3.5. Let's check. Was that a restricted value? No, the only restrictions were -4 and 2, so this should be fine. Let's try one that has more terms in it. So, in order to see the lowest common denominator, just like we did when we were adding and subtracting fractions, we need to factor the top, or we need to factor the bottom, rather. We don't need to factor the top. Z plus 2, Z minus 2. Plus 10 all over, this is going to be 6 by Z plus 2, just common factor, equals 1 over Z minus 2. So now we can see the restrictions. The restrictions are Z could not be -2 or +2. That would make one of the denominators 0. The LCD, we've got a 6 as our biggest number. We've got a Z plus 2. And we've got a Z minus 2. So now we're going to multiply both sides of the equation by that LCD. So we do it to the whole side. 6, Z plus 2, Z minus 2 to one side, and 6 by Z plus 2, Z minus 2, running out of space, on this side. Okay, as I multiply through, notice what happens. Over here, the Z plus 2's and the Z minus 2's are going to be gone. They're going to divide out. So really, I'll just have 6 times 2. In the next one, if I go 6 times Z plus 2 times Z minus 2 times this whole thing, the 6's will divide out. The Z plus 2's will divide out. All I'll be left with is 10 by Z minus 2. And if you find this really tricky, then I'll show you an alternate approach in just a minute. On the other side, the Z minus 2's divide out, so I'm left with 6 by Z plus 2. Now this is a really straightforward equation. We have 12 plus 10Z minus 20 equals 6Z plus 12. We'll just rearrange everything. We're going to have 4Z equals 20, where Z equals 5. Now, is that a restricted value? No, it's not. So this is a solution to the equation. If you find that really tricky when we have multiple terms, I'll show you a slightly different approach. It really does the same thing, but it just looks a little different. So as the potential for errors in multiplication increases, some students prefer the approach I'm going to show you here. You can do it either way. It's essentially the same, but what we do is we convert all fractions to a common denominator before multiplication. So we do the same things. We factor and find non-permissible values. This is the same one we did before. So it's going to be 2 over Z plus 2, just an alternate approach to the same question, plus 10 all over 6 by Z plus 2 equals 1 over Z minus 2. Okay, we factored. We can talk about our restrictions or non-permissible values. So Z is not allowed to be -2 or 2. We can talk about our common denominator, and we did that in the last time we did it, so now we're pretty sure it's 6, Z plus 2, Z minus 2. And what we'll do is we'll convert to that common denominator. So look at the first fraction. If we want 6, Z plus 2, Z minus 2 as our common denominator, what is missing? Clearly, a 6 is missing. In the next one, we have 10 over 6 times Z plus 2. So what's missing? A Z minus 2 is missing. And in the next one, we're missing the 6, and we're missing the Z plus 2. Okay, I'll rewrite this so I have 12 all over 6, Z plus 2, Z minus 2, plus 10Z minus 20 all over 6, Z plus 2, Z minus 2, equals 6z plus 12 all over 6, z plus 2, z minus 2. Once that's true, or once we have that done, we're just going to cross out all our denominators. Now what's really happening when we do that is we're multiplying by the common denominator. So this only happens once we have a common denominator. And you can see what happens. We get 12 plus 10z minus 20 equals 6z plus 12. In the last approach, we got precisely that statement at this point. So we're sure that this is going to end up in the same place. Okay, we'll finish it off. We'd have 4z equals 20 and z equals 5. Not a restricted value. So whichever method you prefer, use that. Let's do one more of these rational equations together. So you may want to pause and just do this. Make sure that you can come up with the same solution. I'm going to do it both ways, so method 1 and method 2, which are really the same. They just look a little different, kind of in the middle. So either way, we need to find our LCD and our restrictions, which means factoring all our denominators. And there's only one that needs to be factored. It factors to x minus 3 by x plus 2, telling us that our LCD is going to be x minus 3 by x plus 2. And that in turn tells us the restrictions. That x cannot be negative 2 or 3. Okay, method 1 was just multiply by the LCD right off the bat. So that's what we'll do. Left side by x minus 3 by x plus 2. Right side by x minus 3 by x plus 2. Now notice what happens when we multiply through. If I multiply this whole LCD by the first term on the left, the x plus 2's will divide out. So what will I be left with? Just 3x times x minus 3. If I multiply into this term, then my x minus 3's will divide out, and I'll be left with negative 5 times x plus 2. On the right-hand side, well, everything is going to divide out. So I'll just be left with negative 25. And at this point, it just becomes an equation that we need to solve. Now you'll notice that as I multiply out, I'm going to get an x squared, so this is a quadratic. Let's put some terms together. We'd have negative 14x. I would need to add 25 to both sides to make one side 0, because that's how we deal with quadratics. Not 25, 15. Okay. And now we can either go to the quadratic formula or we can factor it. And that's in the chapter 4 video, so I'm just going to factor this quickly so that we can see the answer. Okay, there it is in factored form. It tells us that 3x minus 5 is 0, or 3x equals 5, or x equals 5/3. The other solution is x minus 3 equals 0, or x equals 3. So it looks like we're done, but we have to double check against the restrictions. Notice in the first step up there, we said x could not be 3. So we need to cross out that solution. That's not actually part of the solution set, only the 5/3. I'm going to set it up with method 2 as well. And the other method we did involved changing to a common denominator. So here I've rewritten the problem. I've left some space so that I can make that common denominator. The common denominator is x minus 3 by x plus 2. So this very first one is missing an x minus 3. X minus 3. So I have to multiply it by that on top and on bottom. The next one is missing an x plus 2. So I multiply it by that on top and on bottom. And then the right side is fine. And you only need to be able to do one of these methods, whichever one resonates best with you. Okay, let's multiply out the tops. We'll have 3x squared minus 9x. And that's all over x plus 2 by x minus 3. The other one's going to be minus. It'll be 5x plus 10 all over x minus 3, x plus 2. And then over here we'll have negative 25, x minus 3, x plus 2. And the idea here is, now that we have a common denominator, we're really multiplying both sides by x plus 2, x minus 3. But the result is that they're all gone. Now be careful as you run this through. We're still subtracting all of this right here. So I need to show it in brackets. I'm subtracting 5x plus 10. And then, of course, as we solve, it's going to work out to be the exact same thing. Same result. As before, we need to double check the restrictions. 3 is no good, so cross it out. The only answer is this 5/3. Okay, so our final answer is x equals 5/3. Next, we're going to take a look at a couple of word problems. Rational word problems often involve equating rates. So here we've got a question about factoring rates. Karina can factor 500 quadratics in 8 hours. Working together, Karina and Cedric factored 500 quadratics in 6 hours. How long does it take Cedric to factor 500 quadratics? What I often like to do in these questions is say, what is the basic equality we know about? We know that Karina's rate plus Cedric's rate equals their combined rate. Okay, now can we find an expression for that? Well, the question is, how long does it take Cedric to factor 500 quadratics? So let's make that x. Let x equal number of hours for Cedric to factor 500 quadratics. Okay, and now we'll make some expressions. What is Karina's rate? It's 500 quadratics per 8 hours, or 500 over 8. What is Cedric's rate? Well, it would be 500 quadratics per x hours. And their combined rate, we know, is 500 quadratics per 6 hours. If we can come up with those expressions for rate and realize that this is the basic information we're given in the question. If we add those two rates together, we should get 500 per 6 hours. If we can do that, then we should be okay to solve it. So usually in word problems, it's the setting up, not the solving, that's tricky. Karina's rate is 500 over 8. Cedric's rate is 500 over x. And the combined rate is 500 over 6. Okay. Obviously, x can't be 0, but that's pretty intuitive. It's not going to take him 0 hours to factor 500 quadratics. The LCD here. Well, between 6 and 8, there'd be an LCD of 24. And we also need an x. Now, if you happen to use 48, it's not the end of the world. That's not the lowest common denominator, but it will still work as a denominator. Let's go through and we'll multiply each term by what it needs to make that common denominator of 24x. So this one needs to be multiplied by 3x over 3x. This one by 24 over 24. And this one is going to be multiplied by 4x over 4x. So that's 1,500x plus 500 times 24 is 12,000 equals 500 times 4, or 2,000x. And all of these were over 24x. Okay, this is using kind of method 2. And then we're going to divide all those out. Okay, or you could have done it the other way. Just multiply by whatever, by the 24x. That gives us 500x equals 12,000. Divide both sides by 500. And x is 24. In other words, it takes 24 hours for Cedric to factor 500 quadratics. Doing the same problem by the other method, we would just multiply both sides by 24x. This is how I'd prefer to do it. But again, it makes no difference. And then we multiply in over here. 24 divided by 8 is just 3. So this is going to be 3x times 500. Multiply over here. Well, the x's will divide out, so that'll be 24 times 500. And if we multiply on the other side, 24 over 6 is 4. And we still have our x, so equals 4x times 500. And it's going to work down to the same place. You'll still get x equals 24. Same answer. We'll do one more classic rates question. And that's one that involves distance, rate, and time. So I've got it up here. D equals RT. Distance is rate times time. A car makes a round trip between the towns of Aville and Bville. Okay, I'm going to draw that. Here's Aville, and it goes to Bville. And then it comes back. Okay. They're 160 kilometers apart. Because of the traffic, the average speed on the way back is decreased by 16 kilometers an hour, and the trip takes half an hour longer. What's the average speed on the way to Bville? So again, let's look at the basic equality here. It's saying that time on the way back is a half hour greater than time on the way there. So time back minus time going would be a half. Okay, that's the difference in the time. Now we'll need to find some expressions for the time. So distance is rate times time. We could also say time is distance over rate. And that's a rational statement. So that's probably one that we'll use here, seeing as it's the section on rational functions or rational equations. So let's see. We're looking for the speed going. So let x be average speed to Aville, or to Bville, rather. Now, why would we let x be that? That's because it's the thing we're looking for. It follows then that x minus 16 is the average speed from Bville, or on the way back to Aville. And we know that distance is rate times time, so t equals d over r. We want to make an equation about time. This is our basic thing we need to deal with. So if we said time going, that would be distance, which is 160, okay, distance over the rate, which was x. Time coming back, well, that's still a distance of 160. And the new rate on the way back is x minus 16. Now we're ready to set up an equation. So time coming back minus time going is 1/2. Once we've got the equation set up, the rest is going to fall into place. So let's state our common denominator, our restrictions. LCD here is going to be 2 times x minus 16. Restrictions, x can't be 0 or 16. And that makes sense because if x was 16, then the speed on the way back would be 0. Can't have a speed of 0 and get anywhere. So now let's just multiply both sides by that common denominator. 2 by x minus 16. What does it leave us with? Well, on this side, the x minus 16s are going to divide out. So we'll have 2 times x times 160 minus the next one, the x's are going to divide out. So that'll be 2 times x minus 16 times 160. On the right-hand side, the 2's are going to divide out, and we'll be left with x by x minus 16. Following it through, that'll be 320x minus, let's multiply this all through, so 2 times x times 160 is 320x. Negative 2 times negative 16 times 160. Maybe we need to get a calculator for that. 2 times 16 times 160. I'm just doing it with the positive values because I'm going to decide whether this is positive or negative. It's a negative times a positive. That'll be a positive 5120. And over here we'll have x squared minus 16x. Let's clean up the left-hand side. So we'll have 5120 equals x squared minus 16x. We can either factor or use quadratic formula. And probably the factoring is not that intuitive here. It happens to factor to x minus 80 by x plus 64, giving us solutions of 80 or negative 64. I'll put up the quadratic formula, though, as well. And you can see that you'd get to the same place. So we have answers of 80 or negative 64. Do they both make sense? Probably not. The average speed to Aville is probably not negative 64. So, not a reasonable answer. The other one is reasonable. So the average speed to Beeville is 80 kilometers per hour. And you could double check it. That would mean that on the way there, going, it would take, the time would be 160 over 80 rather, or 2 hours. Coming back, the time would be 160, that's the distance, over the new speed, which is 16 less, or 64. And that's going to give us 2.5. So clearly it does take half an hour longer this way.